Every architectural and engineering marvel of our time, of all time, was preceded by and dependent upon a handful of professionals armed with a handful of traditional tools. A compass, a transit and a level. The professionals? The honourable and ancient profession of the surveyor. In the 1960s, a new technology called LiDAR revolutionised the task of the surveyor. Generally mounted on aircraft or spacecraft, the system combined lasers with GPS positioning to scan large areas for applications like oil exploration, power line planning, or flood control planning. NASA had a LiDAR system on the first Mars lander. Then, in 2008, WH Pacific was the first in the Western Hemisphere to bring LiDAR scanning technology down to Earth with the Lynx mobile mapper. This laser scanning system allows surveyors to get up close and personal with the terrain. Clay Wygant is WH Pacific's project manager for scanning services.
The way the system works is the sensors pulse at about 200,000 pulses per second. They travel at the speed of light. There's two sensors, so you have this potential of 400,000 pulses or returns per second as you drive down the road.
As the Lynx moves down the highway, the system scans about 90 meters on both sides of the roadway.
A pulse goes out and a return comes back, and what ends up is we've mapped the environment that we drove through. The equipment itself relies on a GPS signal, so the GPS constellation that we have, it's tied to that, so you know your position as you're moving along with the traffic.
A survey that might have taken several weeks with traditional methods can be accomplished by the Lynx mobile mapper in an afternoon. Unparalleled speed. The information gets to the designer, the engineer, the owner faster, saving time, saving money. Unparalleled detail. The Lynx provides 3D measurements of any object, large or small, within the scanned area. For instance, it not only captures the dimensions of a tree, it will do the same for a leaf on that tree. Here, the Lynx is scanning a section of an interstate highway in Albuquerque, New Mexico.
We've come through and we've driven and scanned this entire area. What we wanted to know was the measurement that we saw on the bridge.
The idea was to make sure the posted clearance on the bridge matched the measured height on the scan. In this case, the posted clearance was correct, more than enough for even large trucks to pass.
An engineer might want to know the height of these barrier walls to see if they're in compliance or not. Might want to know the dimension between the carriage lanes. And so this carriage striping coming through here might want to actually know about the condition of how these piers are looking, if there's appears to be something missing from one, like a hunk of concrete.
Using traditional methods to gather this information would involve closing down lanes, require permitting, a traffic engineer, traffic control personnel, and surveyors out in the traffic.
In our situation, in our scan, there were no lanes shut down. We captured all of the information and we mined it right here in the office rather than out in the traffic.
Some people might think that all this high technology would be more expensive than traditional surveys.
And actually it isn't. We're very competitive in the pricing. There's a value added to this service. Even though the price is the same, there's a greater value in this data set than the data set that you would get from a conventional survey or from a conventional method. For the same price, this is the way to go.
Primary applications of the mobile mapper are engineering surveys. However, it's demonstrating its value in many other fields.
We've had a great run over the last 5 years of different types of projects, everything from endangered species, habitats, to culturally sensitive markers, to incredible riparian study along the Snake River, 44 miles of the Snake River through Hell's Canyon. We worked on a movie one time using the same technology and the same concepts to create this model for animated characters to be built on. Sure, we do lots of bridges and roads, but there's all these other aspects too.
Accuracy, detail, speed, all at a competitive cost.
This is the way of the future. I think the future is now. It's not in the future, it's now.